Hey folks, how's it going? It's Mr. Murray coming to you with a do now for course 1 CP for Tuesday, June 2nd, 2020. All right, so what I have for you here is 4 sequences, and for each sequence, I want to know if it is geometric, arithmetic, both, or neither. Now remember, we've just started geometric sequences. Yesterday we did a recap on arithmetic sequences and then introduced geometric. If you haven't watched or done those activities, I need you to do those. Those are important before you do this one. We talked about a geometric sequence in terms of repeated multiplication and an arithmetic sequence in terms of repeated addition, or you could say subtraction. Okay, so I need to know for each of these, is it arithmetic? Are we adding? Is it geometric? Are we multiplying? Is it both? Could we be doing either of them or neither? We can't find a way to multiply or add. If it is arithmetic, please state its common difference. And if it's geometric, please state its common ratio. All right, so what I need you to do, take a look at these 4 sequences, pause the video, determine if they're geometric, arithmetic, both or neither, stating the difference if it's arithmetic, the ratio if it's geometric, and then when you're ready, unpause and you can see what I got. Okay, so this first one here, 1, 4, 7, 10, 13. We can see that we're adding 3, adding 3, adding 3, adding 3. This is arithmetic, and it's got a difference of positive 3 because we're going up by 3 from term to term. Okay, as a recap, the explicit rule here, there's a couple ways you could write it. We could write it as 1 plus 3 to the n minus 1, or we could write it as negative 2 plus 3n. Okay, because if you plug in 1, you need to get 1, and since you know it's going up by 3, well, you need to add, this needs to be negative 2, so that when you plug in 1, you get 1. So the mx plus b version of it. Okay, second one, both. Okay, you could either see it as a geometric sequence where we're multiplying by 1, or an arithmetic sequence where we're adding 0. So it could be seen as arithmetic, difference is 0, or geometric, ratio is 1. So for example, you could write this as f of n equals 1, f of n equals 1. You could write times 0 to the n. Ooh, no, that wouldn't work, would it? No. 1 times 1 to the n. Not to the, I'm thinking the difference, okay? Not very eventful in any case. All right, third one is geometric with a ratio of 5 because 2 times 5 is 10, 10 times 5 is 50, and 50 times 5 is 250. What we'll learn is this will be f of n, you could write it 2 ways, 2 times 5 to the power of n minus 1, or 2/5 times 5 to the n. Because that's what you would need so that when you plug in 1, what comes out is 2. Because 5 to the 1 is 5, and 2/5 times 5, the 5's cancel and you get 2. Last one, this is neither. This is actually called the Fibonacci sequence. This is not arithmetic or geometric. It's a rule in which you start with 1 and your next term is 1. So it says let the first term be 1 and the second term be 1. Then every other term is found by adding the 2 terms that came before it. So you can see how it's naturally a recursive rule. To get any term, there's no way to do it except by finding the 2 terms before it. Okay? So you can see 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. But for example, there's no consistent number you can add to get from a number to the next. Right? From 1 to 1, you would need 0. But 1 plus 0 isn't 2. From 1 to 1, you also need to multiply by 1. But multiplying by 1 doesn't get you from 1 to 2 either. So no way for it to be arithmetic or geometric. So hopefully you're able to get these 4 right. Today we're going to continue with our investigation of geometric sequences. It's most likely going to be fairly abbreviated, as we are going to spend the remaining chunk of the year talking about kind of a little bit about exponential functions, and then thinking about how we can use different types of models, exponential, quadratic, and linear, to investigate real life phenomena. Best of luck, folks. Don't forget to love math, and remember, you can do it.